Hello everyone, today I'm going to be talking about Ernest Rutherford, a British physicist. At around 1911, a British physicist, Ernest Rutherford, carried out the famous gold foil experiment. He did this to understand the structure of an atom along with Hans Geiger and Ernest Marsden. The reason why Ernest carried out this experiment was that he wanted to test the plum pudding model to see if it was an accurate or if it was a good representation of an atom. Let me show you guys the setup of the experiment. The setup consisted of a lead box with alpha particles that would shoot to the gold foil, a thin layer of gold foil, and a fluorescent screen which detected radioactivity. Now let's take a closer look at this lead box and alpha rays. So he used a source of alpha particles. This is the same as a helium nucleus. It is basically a helium particle with 2+ charge, and it consists of 2 protons and 2 neutrons. These were locked in a lead container with a very small slit. This ensured that the alpha particles only came out through a small opening and traveled in a straight line. But why did he select alpha particles in the first place? Well, the alpha particles were having high energy and were heavier. So if we say an atom is like a pudding of positively charged particles with electrons embedded in it, then the particles will pass straight through it. This is obvious because the heavier the particles are, it is easier to pierce through the lighter pudding structure of an atom and will pass through it. Now let's take a look at this gold foil. He used this very thin gold foil on which alpha particles would bombard. Why did he choose a gold foil? Well, this is a very thin gold foil and was estimated to contain approximately 1,000 atoms. So the lesser the atoms, more convenient the experiment would be. 1,000 atoms seems like a lot, but actually if you consider the size of the atoms, it is very little. Lastly, let's move on to this weird looking circle. So what is this circle? Well, it is a screen. It is a fluorescent screen that will help us detect radiation. That means that the screen will glow or emit fluorescent light whenever alpha particles will hit it. So this will keep track of the alpha particles. So let me show you guys a real model of how this whole experiment took place. So this is how it looks like. This is the lead box, which is right here, and this is the gold foil, which is right here, and the fluorescent screen. Now let's take a look at the expectations. Now, what should really happen ideally? As we know, the Thomson's model suggested that an atom is a sphere of positive charge with negative electrons embedded inside it. It was expected from the Thomson model that it will show a large number of deflections. Now let's take a closer look at the results. There were 3 different results. Let's talk about the first one. Majority, now I'm stressing on majority of the alpha particles went through the gold foil and hit the fluorescent screen. Secondly, some of the particles were deflected by small angles. Deflected meaning it was slightly shifted to a degree. Now, lastly, very, very few, most say 1 in 12,000 of the results of the particles were able to bounce back. Now, what do these results mean? Now, let me show you what these results mean. The first one being that it passed right through. It meant that if this is an atom, the majority of the atom is made up of empty space. So it allowed the particles to just pass through and hit the fluorescent screen at the end. The second result being deflected. What is deflected? It means it shifted by an angle. So what does this mean? So as I mentioned, alpha particles are made out of positively charged things. Alpha particles are positively charged. Therefore, there must be a substance or center that is positively charged. What does that mean? So, when a positive and positive meets, it deflects. On the other hand, when a positive and negative meets, it attracts. So, this meant that the alpha particles hit a positively charged thing in the middle, which we now know as nucleus, and it bounced off. And lastly, when it bounced right back, which is the third result, this meant that it hit the center of the very dense positively charged substance, which we now know as the nucleus. Now I'm going to refer to as a nucleus from now on. And what does this result mean? As I mentioned, very few of the particles bounced right back or deflected. It meant that this center is very, very small compared to the size of the atom. So it is a very tiny substance, and now we know it as nucleus. Now I'll recap everything that has happened in Rutherford's experiment. First being that it passed through. It meant that the atom is made up of empty space, majority of the atom. Now second, the particle deviated or deflected. This meant that there is a center that is positively charged inside an atom. Third result being that the particle bounced right back. This meant that it is a very tiny center, which we now know it as nucleus. Now, thank you for listening, and I hope you have a wonderful day. Bye!